so that we can give the recording to clients, people who aren't here, so they can view the presentations, and also for evaluations for PMs and such. So next on, students, please check out the schedule. I've posted in the chat, and I think if you've arrived late, you won't be able to see it. So I will repost it in the chat once again. Just go to the website, scroll down to your category, and you'll be able to see when your presentation time slot is supposed to be. As I mentioned before, it's very hard to keep track of time, make sure some presentations are longer, some presentations are shorter. I'm going to do my best to be the time police throughout the event, but please ensure that your whole team is present for at least the time slot before and after, just in case we do roll over time. Judges and clients, please have your evaluation forms ready. If you don't have them, if somehow you missed the orientation or you lost the link, let me know. You can message me privately through the chat and I'll send you the links that you need. If there are any guests, enjoy the presentations. For the students, please be respectful and quiet throughout everyone else's presentation so that we can hear and everyone gets their chance to show off what they've done. I'll be guiding the event, as I said, so if anybody has any questions at any point, feel free to message me in the chat. Or if there's a quiet time in between presentations, just feel free to yell out your question and I'll do my best to help you. I'm just gonna get my paper out. Perfect. So just to give a little bit of an introduction to today's category, Accessibility 2. So here we have some mostly second-year students who were given a client, and the client has various accessibility needs. The students had to meet with the client, explore what kind of solution would be feasible to best meet their needs, and then go through all the various prototyping steps. So everything from full-on drawing to build, and hopefully come up with a functional prototype to show off to the client at the end of the semester. We do have various projects or various clients, so we'll see it all. The teams won't all be focused on one solution, and the teams should be explaining what their specific project was at the beginning of their presentation. So I'd like to welcome all the judges. Thank you again for taking the time to spend the morning with us. And I'll just get you guys to, I guess I should introduce myself first. I haven't done that yet. My name is Alex. I'm the manager of the Manufacturing Training Center and the Brunsfield Center here on campus. So the Manufacturing Training Center is a training center where we teach students on how to use various manufacturing equipment, everything from the drill press to the mill, the lathe. And the Brunsfield Center is a machine shop where the students can come after having being trained, can come work on various projects, whether it's personal projects, these G&G projects, or anything above. So that's kind of my role in all of this. So I'll just go through the list of judges, and if you can give us a small introduction of who you are, what you do. So we will start with Christina.
Hi, my name is Christina Lepp. I graduated from the University of Ottawa years ago in the mechanical engineering and biomedical option, one of the first years that they had that option. I worked several years at a place called Abbott Point of Care, and I've recently moved over to Canada Post.
Perfect, thank you, Christina. Ted Yip.
Hi, my name is Ted Yip. I'm a prof at the University of Ottawa, Electrical Engineering. I joined the university a long time ago, almost 35 years ago.
Perfect. Thank you, Ted. And So Deepthi,
Hi guys, good morning. My name is Dipti and I am a director of delivery system engineering at Canada Post. I have a degree in electronic engineering and I've been in the industry for 17 years working on various different electronics and system design and design architecture. So I'm thrilled to be here today with you all. So thank you.
perfect, thank you. I'm just checking, I think we have a judge that may not have arrived yet. Lithuania, but no matter, hopefully they'll be able to join us a little later. So in the meantime, can I get group C22 to get ready, get your presentation, get ready to share your screen for the presentation. And we'll get started. Once you guys are ready, just go ahead, share your screen, and then we'll give you a go to get started. Perfect. And before we launch into it, I just want to make sure all the judges, do you guys have your forms in front of you ready to go? Perfect.
I did see the other judge in one of the other rooms earlier. So I'm not sure if that person's lost somewhere.
Yeah,
They were around, so I don't know if we want to try to find them.
I think I saw them in the orientation.
Yeah.
So I'm
Yeah.
gonna quickly.
So Latanya is also from Canada Post, so I tried to ping her. I've not seen a response. Yeah.
Okay, I'll send a message to some of my colleagues in the other rooms and see if we can track her down.
Yeah.
And if so, I'll try to bring her back to the right room. So in the meantime, C22, if you guys want to, whenever you're ready, we can get started.
Okay. Good morning. We're group 20, Power Grabber group 2.2. The group's comprised of Palmer Insull, Ethan Wazell, Jermaine Sublet, and myself, Kilmiwa. So many individuals have limited grip strength due to medical conditions or age. Possible examples are individuals with neuromuscular disorders or arthritis. Our client this term educated us on current solutions and how they're inadequate to meet their specific needs. With this education, we generated the following problem statement. There is a lack of an effective powered grabber that is both lightweight and capable of picking up and manipulating objects. It was important to us to make the product lightweight, comfortable, and able to pick up sufficiently heavy objects. And the grabber is meant to aid those with physical conditions when picking up and manipulating objects that would cause strained movement and likely require external assistance. The value that a potential solution would bring to our client and possibly others motivated us to make a thoughtful design decisions and meet other requirements as best as possible. After meeting with the client multiple times, we decided on the following user requirements. Palmer, I think your microphone might be muted.
Sorry, I have 2 minutes. Where we excel. So yeah, our design based on those choices that we made earlier, we wanted to make basically a very lightweight grabber, which we've achieved under 1 pound using the leverage to basically use a cantilever effect, allowing the user to pick up heavier objects. We've made a generic strap holder that's ergonomic and allows it to be adjustable for our client and multiple clients. The use of a large torque to weight ratio servo allows the grabber to reach the requisite grip strength while remaining very lightweight. And we've also introduced and created a wide space capacitive touch sensor control panel so that the controls can be used without the addition of force and can also be done very easily. So this is what our design looks like. So we've adapted a kind of on the market reacher grabber to be able to be motorized using a winch. We have an ergonomic grip that consists of an elbow pivot point with a strap mount, as well as a front handle that the hand goes underneath. This configuration is designed for the right hand as the handle rotates around, and also consists of a magnetic mount for the button controller, a blue control box which houses our simple but effective control circuit, as well as our winch mechanism, which is able to close the jaw of the claw very effectively and easily. So, I'm now ready for a demonstration of our design. Here we actually have our claw all put together. So, of course, this was designed for a client who has a much smaller arm, but I can kind of show you how it's able to pick objects up. With the control panel here, we have capacitive touch sensors that really you can just put our hand over and they light up. You can hear that's the sound of the motor whirring. And our claw, upon pushing the button, closes like this and opens right back up. So we tested it and it's able to pick up objects around, 0.6 to 0.8 kilograms, such as this box here. It's able to pretty well pick it up. And yeah, we're pretty happy with our prototype in terms of its grip strength. Of course, we weren't able to properly test the ergonomics, but we do believe that they would be comfortable and effective. And we look forward to developing this product further on our own time if we get the opportunity. Thank you very much for your time. Do you have any questions?
So just before we go into the question period, can you show us the demo again? I think it was a little late on pinning it, and I think I may have pinned it now. Some of the judges are saying that. So if you go before the demo, Ted-Yip, if you go into the top right corner of your screen, you'll see a view button. You can then change that view to gallery.
Swap video and share screen.
No, so in the top right, you might be stuck in the full screen view then. It's spotlight people.
I'm now in not full screen. You
Okay.
mean view option?
Yeah. So go to gallery.
Gallery. Where is that?
In the top right, and when you hit the click on the view button, you'll then have like a standard view, gallery view.
Oh yeah, gallery view. Yes.
Okay, and then if you find Polymer's little cube.
No.
Then I'll just get whoever is sharing their screen to stop sharing their screen. Perfect. And then I still can't spotlight people, which is annoying. In gallery view, do you see Polymer's little square?
Palmer, you mean? No.
Okay, you may have to click on one of the arrows to swap through the gallery views.
Okay. I have only two screens.
Speaker. Maybe even better if you go back to the top right and you click on view, you can change it to speaker view. And then once Polymer starts speaking, he'll be spotlighted.
Yeah. I have the speaker view, yeah.
Okay, so Polymer, do you want to go and start your demonstration?
Yeah, of course. Sorry, I'll show it off again. So right hand, the elbow for a much smaller arm goes into the grip here. The strap goes around, and the other front part of the hand goes underneath the handle and supports the hand from underneath so that it can be lifted up like this. Our control panel's right here, and pushing the buttons allows the claw to close. We can lift it, move it around, manipulate however, and put it back down and press the other button to open the claw.
Perfect, thank you. So now I'll open the floor to judges. You can just go out and throw your questions.
I can go. Oh, go ahead.
Oh, sorry.
No, go ahead, Ted.
Go ahead. Palmer, question. What limits the weight that you can pick up from your device?
Well, the
You
limit
said
for
it's
the,
about 0.6 kilogram
yeah, of
or
course.
kilogram.
So if you're making the assumption that, you know, it can pick up like a grocery bag or it can go through a hoop, there's no limit on terms of the actual device. But in terms of gripping something, I guess it depends on, you know, how frictional it is as well as how it's being gripped. So it's quite hard to determine that. But if you're grabbing an object like this, we can exert, I think about 15 kilogram centimeters
Okay.
on our axis, which means, you know, we can do about, I think 1.5 pounds of force, essentially, which gets converted to about, you know, 1.1 pounds of force on our kind of actual like grip. So between the two jaws, there's about 1.1 pounds of force. So, you know, times coefficient of friction, basically you get how much you can kind of hold in terms of the weight.
What if it is greasy?
If it's
surface?
greasy. That wasn't really like one of the kinds of objects that we were told we might need to deal with. But in that case, that would pose more of a challenge. We do have, this grip does come with rubberized ends, so it's able to kind of pick stuff up more effectively. It's more, you know, frictional. But
Okay.
yeah, I suppose that's something we haven't completely considered.
Okay, thank you.
Hey, one quick question. Did you guys ever try to do a user acceptance test, like have somebody use this in a real time, like somebody with a deformity use it?
That's a great question. Unfortunately, just due to our time constraints and you know, when we're actually able to be on campus, start working, most of our client meetings, we weren't able to fulfill that, which is unfortunate, but yeah, unfortunately not.
So just a question from a non-judge about part of the Tetra team for which this is being designed for our client. What is the total weight of your grabber overall with all equipped as you've shown it?
With the battery pack kind of attached to the actual device, it is about 1.3 pounds, which is quite heavy. But with the battery pack and the control pack kind of off the device, it weighs less than a pound, all in all.
Okay, very good, because that is one of the constraints of designing something like this, is for a young user to have the weight. And I like the idea of the counterbalancing, because the object is counterbalanced with the weight of your controls or your motor.
How long does the battery last, and how do you charge it?
So we opted to use, in this case, we have an external power supply because we had some issues with our batteries, full disclosure. But it can be powered off of a kind of a regular phone battery bank at 5 volts. It draws at peak around 1.1 amps. So, you know, given a reasonable battery size, you could last, 2 to 4 hours kind of continuous operation, but likely this device isn't used continuous operation. When it's in its kind of open state, it's not drawing any power just for the controller, so it's kind of negligible. But when it's being kind of open and closed, it draws 1.1 amps.
Perfect. So thank you very much, C22.
I was just going to mention, so the client that it was made for, do you have something to say?
I really like it.
Thank you very much.
Thank you so much. Thank you.
What is it that you like about it? That you can pick stuff up off the ground? Yeah. And that it can be small. Yeah. It's pretty amazing because you know, for the pediatric population, there's far less options, and so so it was really amazing to see something made for such a small little thing.
Has she tried, Clinton?
When we came in, they just had the diagram, so we didn't get a chance to physically use it, but we did get to see it kind of firsthand on a diagram and kind of.
And
look
then
through it.
and in like a 3D modeling type.
Can you see that?
Oh, okay. Sorry.
Oh, good.
Yeah. So we did get to see it. Pretty
And they got to see how she moves and how
yeah.
you know, she functions, so that they could kind of go from that as well.
Great.
Awesome. Do you have anything else to say? Or are we all done? All done? Okay. Thank you.
Thank you so much.
Thank you so much, guys. That's awesome. Can't wait to see how it works with her. I hope it goes well. So thank you very much, C22. I'll get C32 to get ready. Start sharing your screen. Get your mutes unmuted and stuff. Just for the judges, if you can fill out your evaluation form while the next team gets ready. And C32, whenever you're ready, we can get started.
Awesome. Are all the judges ready? Sorry, I can't see the actual Zoom screen. I'm just gonna.
Yep, we are.
Awesome. So I'll jump right into it. So I'm just gonna start a little bit about talking about our client. You just saw her on the screen. Her name is Maeve. She's a 5-year-old girl with arthrogryposis. This kind of limits her hand strength and grip strength and limb mobility. So our target customer base for this product would ideally be someone with limited mobility. This also includes children, since our product is resizable. It also includes people with spinal cord injuries. I'm also in a wheelchair. It's been about 8 months now. I fell off my mountain bike and broke my back. And ever since then, I use the grabber stick a lot. So it's been really interesting actually working on a product that I use daily. So yeah, I have a list of all these people that this product could benefit. As well, if you're also able-bodied and can't reach certain objects, you could also use this product, no problem. So here is a 3D rendering of our product. Just a warning, this presentation is kind of going to move fast, so please do soak in this design while it's on our screen here. I'll point out a couple of key features. There's our top cap. You'll notice that it's wider than the actual handle, so that people can slide their hand in and just have the arm be retained to their hand without much grip strength, because their hand's not sliding off. There's 2 easy to push buttons up here that are semicircular shaped. Our claw assembly in the front, we have an integrated hook, so you can kind of grab bags and push and pull things. Also, you can't see right now, but there's a magnet up here, so you can grab magnetic objects. Next, we have a rechargeable battery pack. We'll talk a little bit about battery life and that later. And we have some wrist support, and we have a carbon fiber tube that is holding it all together, which is actually custom and it's very lightweight. So that was our design. This is kind of all of our subsystem parts exploded. So you kind of have a better idea of how this was actually built. Our team member Zitai had a 3D printer at home, so he was very easily able to print all of this stuff out. And this is kind of how everything was assembled. We can come back to this later if you have any questions. So here are our product specs. Kind of the most important part is the weight. We kept it under 500 grams because Maeve can't carry things that are very heavy. We have a gripping force of about 2 kilograms at the tip of our grippers. So we're using a 20 kilogram per centimeter servo, and our claw assembly is around 10 centimeters long, which gives us a gripping strength of 2 kilos. Battery life is pretty great. It can be standing by for 300 hours, or if you're moving the clock continuously for 30 hours. That's our battery life. Takes around 10 hours to charge. It's around the battery capacity of your phone, if that's a good reference. I want to talk a little bit about what our onboard electronic system looks like. So Zitai has drawn us a nice little schematic here that takes up the major part of the screen. We have 2 18650 batteries wired in parallel that powers our entire system. We have a battery management system to make sure we can charge those batteries using just a simple DC 12 volt barrel plug that you can buy on Amazon. This charges the batteries up to the correct level, make sure that they don't discharge past a certain amount. We have an on and off switch to cut off power to the entire circuit. We have an Arduino Nano taking account of all of the logic for the system, does all the signal processing, and it hooks up to the 2 switches that we see here, and it connects to the claw. We have a Hall effect sensor to make sure we're not providing too much power to the servo to burn it out. So this basically in practice means that the claw will only get so tight around an object before it stops providing current. So yeah, that was our onboard electronic system. And just a quick product comparison, our product is better because it's tailored to people with limited mobility, and it's kind of built from the ground up. So we're able to kind of custom tailor it to fit different people's needs. Also, it's just way more durable than any other design that's currently on the market. So with that, we're going to jump right into the live product demo, and I will stop sharing my screen. There we go, and so Ty will take it away.
Hello, can you see? Can judges see me? Okay.
Yeah.
Okay, great. So here's our actual product made here. We asked May what color she likes. She said pink, so we printed in pink for her, especially. Here, my hand is a little bit too big, but it just barely fits inside. So I will just. So we have a wrist wrap to secure it to my arm, so that it won't fall off. It won't fall off in any way, and we can turn it on. We have 2 big buttons here. We can close it, open it, and we have different modes for controlling it for, well, fine control if she wants. So as Tony mentioned, we have a magnet in the tip. So here I don't know if you can see, I have a small metal wrench here. Just imagine this is a metal toy. She could pick up using the magnet very easily for well, small objects. And here I have a glue stick. It's a small, medium to small size object. I can pick it up and use it here. And it's all battery powered. There's no external power connection here. And also here we have a heavier object. It's around 600 grams water bottle. I can try to pick it up. Here you can see pick up, no problem. Yeah, and here's up here. Yeah, we have our don't know if you can see that. We have our power switch here and the DC barrel jack for charging. Yeah, that's the system.
Cool. So now we'll open the floor up to some questions if any judges want to jump in.
I have a question.
Sure.
It looks like the arm, the extended arm is quite long. Can that be shortened?
Yeah,
let's say I want to grab a water bottle and then drink the water.
We asked our client. Clinton said the most likely use case is she will pick up an object from the ground and move it to the table and grab it with her hand and use it that way.
Oh, okay.
So this
is there a chance to shorten it?
Yeah, we can actually shorten it by loosening the screws here, and we can push the whole pipe this way, so it can be shortened.
Can we add a motor to make it adjustable?
We actually discussed this with our client, and we think that will add too much unnecessary weight. So we.
Oh, okay.
Yeah.
Good. Thank you.
No problem.
Hey guys, I just want to say, first of all, amazing presentation. Kudos. Great job. Lovely background. The way you guys set that up and the way you explained it was really, really good. And even you took the client color into perspective, which is amazing. So that's great. So I have 2 questions, but I think Zatai actually answered one of my question with its question. So yeah, like I was going to ask about the scalability roadmap, right? Like, have you guys thought about it, how you can scale this and how you can redesign for other clients and stuff like that? maybe if you could shed some light, I would love to hear that.
Yeah, that's a great question. I can take that one. So basically, right now our product is very kind of customized to one user. It's parts are being 3D printed, and it's very much a premium product. The way we can scale this up is we've discussed starting injection molding for some of these products, so we can pump out these plastic parts faster. That would dramatically shorten our production time because all we need to do is assemble it to a tube essentially. And then right now Zatai has all the electronics on what's called a proto board, which is kind of like a rudimentary way to prototype electronics. So moving forward, we'd basically want that to be a custom PCB so that we can have all of that fabricated and just chuck one part into the box and be done with it. So I hope that kind of answers your question on scalability and making this profitable.
Totally. Yeah. And my second part of that question was in terms of production, the cost to produce this device and how it compares to what's out there in the market.
Yeah, so right now our device is under 100 Canadian dollars. So the carbon fiber tube is we're looking at around 20 bucks a pop. The 3D printing, the filament is really around $30 a roll, so that's not really that expensive. All of the electronics we're looking at around $30, $40, and the batteries around 10, 15. So that kind of brings our price to $100. But obviously economies of scale, if we buy more, it'll be cheaper, so.
And also, if we put the electronics on a PCB, it will be cheaper too.
Hello. So in looking at it, it's amazing that it can do so many things. So you've got the hook and the magnet and the gripper, being able to grip the end, but also, you know, the big part. What I like about it is that, you know, I look at her and her size right now, and I foresee this being something that can be, yes, you can. I foresee this as something that would last her a long time. Like it's not something that she would quickly grow out of, which is really important again for the pediatric community. And just the ease of use, it looks pretty cool. What do you think?
And I like it because like it can't like really fall off, and like the buttons are so close.
They're so close.
Yeah.
And they're big. Do you like that the buttons are big?
Yeah.
Yeah. Okay. What else? Anything else?
And that like I have something to hold on to.
Mm-hmm.
And it's pink.
And it's pink.
Yeah.
Yeah.
Also that.
Amazing. Thank you so much.
Yeah,
Thank you
it
for your
actually looks
feedback.
more pink
Father.
than you see. It looks more pink in real person. So.
Right. And I mean, even so even just looking at it, just a second, please stop touching. Even just looking at it and kind of seeing that, you know, you have your forearm cuff and then the place where you hold your hand. The only thing that I see in terms of like scalability is possibly making it so that that part could maybe grow or move to be able to accommodate a larger arm or a longer arm.
So while that part can't move, what you can move is when she does grow up, you can kind of slide the pole further out so it's longer.
Right. Yeah.
But that's a good point. If we do make another version, we would definitely take that into consideration.
Yeah, just in terms of being able to hit more audiences and
Totally.
making it like less custom, but more adjustable, I guess.
Right.
Now, the one advantage that I've been involved in a number of attempts at this, and the last two that we've seen are making great progress. The one advantage of this particular unit compared to those on the market and earlier is the fact that the servo motor is contained in the gripper end itself, and there's no wires running through the carbon tube or through the slot. This has been a very limiting factor in two things. One, making it extendable because you have to rewire them. And secondly, it's prevented them from being foldable. And many people would like to carry an object like this, with them somewhere, be able to fold it and have it in the side part of their car seat, or carry it in a big purse. So the other idea too that follows along with is having you could have a carbon tube sliding in a carbon tube and have it twist tight, as many things extension poles do. So you could have carbon. I don't know how that would be done theoretically, only theoretically, but you could have a sliding tube within a tube. So there are many ways of going about it, but the motor at the servo end, or the servo motor at the end, is a great advantage in changing the length.
Perfect. So thank you so much, C32. Great presentation.
Thank you, judges. Hope everyone has a great day.
I'll get the C33 to share their screen and get ready to present. Just a side note for judges to fill out the evaluation form.
Hello, can everyone hear me?
Yeah.
All right, perfect. I just want to say hello to our clients, the judges, and everyone attending today. Our team, we're team 3.3. It was composed of a few members. I'm not going to name them. I'm just going to get into it right now. Our project was the wheelchair tray tablet holder. It was proposed to us by, just want to skip my slide. Okay, it proposed to us by Tetra Society, by Paul, that's in the meeting right now. I want to say hello to Paul. So the project was to design and build a device that was adjustable for a wheelchair tray. So it was supposed to hold a tablet like an iPad and essentially bring it down and up at an angle by the press of a button. So it's an automatic system that would enable to hold an iPad and have it up at a desired angle. The holder had to be light. It had to maximize the tray space when it was down. It had to be removable from the wheelchair, and obviously it had to be able to bring the iPad up and down at the desired angle. So these, just like I said, a few requirements from the client: fully automated device, so electronically powered. The angle had to be adjustable. Lightweight design, and simple mechanism, etc. So these are some current solutions that we found on the internet. Most of them were like type of style of arms that would be adjustable by either pins and or screws, or gooseneck type of solution. We talked about this with the client. It wasn't really ideal because they're complex. They can't be adjustable that easily, and they're not automated. So this is our prototype. It's the SolidWorks model of it. It's automatic. We use electric circuits and a linear actuator to power up the mechanism. So it goes up and down based on the linear actuator that we can see here in the SolidWorks. It's simple, systematic use of space on the wheelchair. It's reliable, and it's also made with cheaper materials for the prototype, at least. So here is some pictures of the system. We have the wheelchair tray, which has Velcro straps, so it can be put on just about any wheelchair. We can see the iPad lifted up at the angle that can be adjusted up or down. We have a cover here for the iPad. It was supposed to originally be the same color as the tray and the same material, but due to time constraints and a few problems, we had to opt out for another option. But the principle is that the cover goes up and down based on the iPad sort of pushing on it. And that is powered by the actuator here that we see in the middle. So yeah, how the system works, it's a linear actuator that's powered by a 9-volt battery. We have a polarity reversing switch, which can put the iPad up and down. Yeah, it goes up and down by the actuator, and we use a few hinges to provide that movement of the angle. Here's some other pictures without the tray. So the actuator, the switch, the battery, the wiring, and this box was laser cutted out of MDF material. And now I'll just show a quick video demonstration since I'm running out of time, of the actual system working up and down with the iPad. So that's the iPad going up from the actuator and the arm that's pushing on the tablet holder. And then we should see it go down as well. And that's it. So that was our project. And I don't know how much time I still have left. I think that's about it.
Thank you very much.
But yeah, so I'm ready for some questions, and the team is ready for questions if you guys have any.
I'll ask a question. When you're pushing the, are there 2 buttons there that need to be pressed, and do they need to be held, or how does that work?
Yeah, it's I'll go back in the slide just to show. If you see it here, the picture is not that great, unfortunately, but yeah, so it's 1 button and it has 2 sides. It reverses the current of the circuit. So it has to be held to be going up, and then if you let it go, it stops. And then the other side, same thing, held to go down. If you let it go, it stops. So yeah.
Okay. And then I guess my other question was, how is it held onto the iPad or the tablet? Is it like, I guess how do you hold the tablet in place?
Yeah, for the prototype itself, we just use tie wraps. So 4 6 tie wraps, 1 in each corner. It held not bad, but obviously if it was to be scaled up, that would be done with, you know, a better material like a bracket made out of steel, or no, actually aluminum, so it's a little more lightweight. Just clean brackets with screws, or welded, or some other better, more reliable solution. But for the prototype, we use tie wraps. Yeah.
I'm just gonna butt in. I think, correct me if I'm wrong, but I think she was talking more about how the iPad is held up onto the.
Oh, okay. I apologize.
Yeah, I didn't hear. If you want to take it, go ahead. I mean,
yeah.
Am I right? Is that what you wanted to know more than?
Yeah. How the
Okay.
iPad itself was held. Yeah.
Yeah, go ahead, Xavier.
Yeah, so the plastic piece here, that's a 3D printed piece. And underneath it has, I should have shown it better, actually. It's a good point. It has a Velcro, so it's on Velcro. The iPad is on Velcro on that piece, yeah. So we have we stuck a Velcro on the iPad as well. So
thanks.
I'm not a judge, but I do have a question. I'm not even a client on this, but is it waterproof so that if somebody's out in the rain, does the iPad get protected?
For our prototype, not fully, no. As you can see, it's not very waterproof for the cover, at least. Ideally, if this was pushed ahead, we'd have a better material and a better fitment for this cover, and it could be waterproof with either a sort of gasket or like a seal. When it goes down, it wouldn't let water get underneath.
Thank you.
Great. Quick question. So first of all, another great presentation. So thank you. Is the spec now just to fit one particular iPad, or is this like looks like it's designed to fit one size of the iPad. It can't go bigger, right? That's how it's designed at this point. Can
Well,
you?
This iPad is a second generation. It was about 7 by 9 inches, if I'm right. So this one fits perfectly. We could go a little bigger. I don't know the dimensions of the other iPads, but it could be, there's a bit of room on the width. It could be a little bigger for maybe the next version of that iPad. Like I said, I don't know the exact dimensions of the other ones. But of course the fitment could be modified to fit other iPads, but there is a bit of room, and it could be a little bigger for a bigger tablet as well. Yes.
Have you guys
I have a
thought
question.
of, sorry.
Oh, sorry. Sorry.
I'll ask one more and then I'll shut up. So have you guys thought of putting a charger right in the same place so that you can charge while watching something on the iPad?
The charger is not integrated in our system. That is a good idea though, absolutely. But it's a 9-volt battery, just like a Duracell you could buy at Home Depot, for example. And those you can buy chargers for, so you could just, our system is like, it's like built in the wiring, but we do have like a connection that's, you could take the battery on or off, and then charge the battery and then put it back. But this Duracell battery, we've used the same one the whole long, and from my calculations, it would be good to run about 14 hours straight, which probably wouldn't be the case, because you lift it up and then you would wait a bit and then put it back down. But the battery could be charged. We just have to take it out. Yeah.
I have a question. What if I do not want the iPad to be stand up this way as shown? I want it to be the other way.
Well, for this prototype, that wouldn't be it wouldn't be possible. Like, you mean horizontally instead?
Yes, that's right.
Yeah, not for this prototype, unfortunately. We wanted to lift a certain way, and we had shown our clients what we were thinking during the process, and it seemed to be right for the users. But yeah, it would only lift up this way.
Your design is impeded by the plank at the back, right?
Impeded?
Yeah,
Like
because you have a piece of wood or plastic at the back of the iPad that would impede the changes in the dimension or in the orientation of the iPad. Let's say if I go to another device like Galaxy, I would have to change the design completely.
Not necessarily. As long as the other tablet's about the same size or a bit smaller, it would fit in our prototype.
Okay.
Yeah.
Yeah.
Okay. Good.
Exactly.
Thank you. Very good presentation.
Thank you very much.
Perfect. So thank you, C33. I'll get D21 to get their presentation ready and start sharing your screen. And just a reminder for judges and clients to fill out their evaluation forms.
Sorry, can you guys see my screen?
Yeah.
Yeah.
Perfect. So hello, our group is a tablet holder for wheelchair trade. And our team is Maysam, John, Clement, and myself. So in this presentation, we'll be talking about the problem, about our product, the product visualization, and the future vision. So the problem that we found is that tablet holders are not properly integrated within wheelchairs, and that there's a need for integrated tablet holders within the wheelchair to better have usability, which is necessary for those kids that have reduced mobility. Now, we also saw that most tablet holders that we found were often like gooseneck arm devices, which are often attached to the wheelchair and not are awkward to set up for best use and to reach easily. So John will talk about our product.
Sorry about that, but I have a problem with the Google Slides right now. Can you continue and then I can show you guys the product physically?
Yeah, sure. So for our target audience for this product, it's accessibility users, their families and caregivers. It will also serve as a good alternative to complex and expensive attachable tablet holders that can hinder or restrict the user's view or fail to satisfy their needs. With our product, most users will be able to gain a sense of self-dependence, which is crucial to building confidence and giving them a sense of responsibility. Moreover, it will save the caregivers or family members the time to install or dismount gooseneck arm devices, especially during travel. This new tray design can be easily tucked away or moved off the wheelchair. There's multiple reasons why this is important for us. We found that it's for comfortability, usability, and safety. It's comfortable to use the product on a daily basis. It should be easy and simple to use and put in a position that will not harm the user. So for some of the product features, we have made it easy to use with a simple press of a button. Once the tray is turned on, you can notice that 1/3 of the tray remains closed, serving as armrest or wrist rests for the comfort of the user, but it also helps people that want to see what the users are doing be able to see them, as the tray will not hinder their vision. You can also see that we've put padding on the sides of the tray so that sharp edges won't harm the users. We also decided to after finishing up the tablet, it can remain stored inside of the tray, and so you have a place to store the tablet. And so for things we want to do for the future, we would like to implement more angles of motion, include preset positions so that the user can come back to the position they're used to and they like. Another thing is to add a remote control, so it's even a little easier than just pressing a button. And finally, create an independent tablet holder. So thank you for listening. And now our group will answer some questions.
I have a question. How is this integrated with the wheelchair?
Hello, my name is Mason. I'll be answering some of your questions. So due to lack of time, we tried to order a tray, but unfortunately none of them were with the thickness we needed. So hopefully we can find a tray with a thickness of 1.75 inches to integrate this tablet holder into it by taking the top off, as you saw in the prototype. For now, we only had the prototype. In the future, we hope to integrate it into an actual wheelchair tray. But for now, we're only doing the prototype.
Good, thank you.
No problem.
Great presentation, guys. So just to build on that question, just for my understanding, how much time frame were you given to from the beginning of this assignment to the presentation day? What is the time frame?
So we had to change a lot of design of our ideas due to our conceptual designs. They were not fit with what our client wanted. So at the end, we kind of had a less time. So I would say we had less than a month to finally work on what we think works the best.
And I do like the way you guys have created the holding of the tablet, because that is scalable, right? Like you can actually make it small, you can make it fit like a cell phone to a tablet, I guess, correct?
Absolutely, yes.
Okay, perfect. Yeah, thank you so much.
Thank you.
Perfect. So thank you so much, D21. If I can get D24 to start sharing the screen, get ready to present. And once again, judges and clients, if you can just fill out your evaluation forms.
Hi, can you hear me?
Yep.
Are we good to start?
Yeah, do you guys have
Let
a
me just
presentation
share
to
my
share?
screen. Yep. All right, can you see it?
Yep.
Okay. Hi, my name's Grace. I'm with Team 2.4, and I'll be showing you our group's project. So the difficulty with using technology for people with limited mobility. It's difficult for wheelchair users and those who have limited range of motion to find products suited for their specific needs that allow for functionality they might not be currently capable of. To operate a tablet, it may be difficult for them to use their tablet properly, meaning they may require assistance from another person, have to use their tablet in an uncomfortable or unaccommodating way, or might not be able to operate one at all. Most tablet cases are not able to stay firmly on a moving wheelchair, leading to them not being able to be used by those with limited mobility, or be at an uncomfortable angle. Everyone deserves independence to the greatest degree they can achieve, and in engineering a solution to our problem can solve this issue and grant people who are in wheelchairs more of a right to their own control. Current products on the market. Current products on the market include a variety of adjustable tablet holders. However, those that operate in a way that's compatible with wheelchairs or wheelchair trays are either highly expensive or do not suit the user requirements. The tablet holders with arms and grips require a level of strength to bend and curve them, while more stationary holders that change angle and adjust are too far to reach. Our design aims to specialize on those with limited range of motion, where other designs aim for a broader demographic. What is our product? Our product is a modified wheelchair tray with a built-in remote adjustable tablet holder. Key features to our design. The goal of our product is to allow wheelchair users with limited range of motion to be able to access multiple preset modes or positions for the tablet to be shown and interacted with. Display mode would feature the tablet upright and vertical, slightly angled for the viewer to be able to see the tablet with space in front of them. Resting mode would have the tablet covered up, facing downward, so the user can access the entirety of their wheelchair tray. Whereas interactive mode would bring the tablet right in front of the user, allowing them to access it via a flat surface and interact directly rather than from afar. There's a simple remote that we have created with 2 buttons for our functions. The first button can move from resting mode to display mode and display mode to interactive mode, where the other button can move from interactive mode to resting mode and display mode to resting mode. Here's a demonstration of our product. And 1 second. That's it. Thank you for listening. Any questions?
Great job, guys. Lovely presentation.
Thank
so, a quick question on the battery life. So, is this motorized and is it like running on a certain battery life, or is this rechargeable?
I believe it is running on a 9-volt battery, so we are working on a battery that has a limited lifespan. I'm unsure of how long it's actually functions for, but I believe it's for a somewhat reasonable time.
Okay.
I have a question. Can you go back to your demonstration? When you close the device, it looks a bit harsh, isn't it?
The reasoning for that might be due to the fact that I had to speed up the video to allow enough time for a presentation. So if I slow it down, you can see it's a lot slower. Just 1 second.
Okay.
So this is at just like the normal speed. So if you see it close like this, it should probably be a lot slower. 1 second.
Okay, now, okay,
Yeah.
it's speed
So
up.
that's at the normal speed. Yeah.
Okay. Do you have any damper to damp up the when it's closing?
Any what?
Damper, damping the motion, so that it's not just flipping up because your tablet can fly somewhere else, right? Or
That's
closing
true.
it.
Yeah.
So use any damper at all?
I'm a bit unsure what you mean by that, but we do have it kind of built in a way where there is kind of tape to kind of secure it and make sure it doesn't go flying. And it's also
Oh, okay.
within a case. So the case kind of snaps to have the tablet in place. So it can't really go flying. It's kind of locked in.
Okay, good, thank you.
And I just want to add that I really love the presentation. All the features were really well explained, and I think it's a highlight. I really like the way that you explain it. You put what it's in the market, the functionalities that were key for your design, and I really understood it very, very easily. So great job.
Thank you.
I'd like to take the opportunity to compliment all three of the groups that have worked on this project. I need to give a bit of background because unfortunately the real client for this is unable to be there. It is representing the therapists who work at the preschool and some of the schools that are run under the CHIO organization. And one of the issues they face is children love their tablets. They want to use them all the time, but it's lunchtime and put the tablet away. But one of the problems is that if you have X number of students and only a few teachers, you're busy running around with tablets falling over. Tablets need to be set up. And one of the I worked as a volunteer at one of those schools. One of the ideal solutions would be to allow the child to have control over their own tablet on their tray, eat lunch, open their own tablet. So that is the ultimate goal. And these products, all three of them, have gone a long way towards solving that problem. Great compliments to all three teams.
Perfect.
I just had a quick question.
Oh, yeah,
So
go.
the prototype, it looks like it's made out of like cardboard. What would be the ideal material there?
So for this one,
Yes. Yeah.
so we're currently making it out of MDF. So it's kind of a bit of like a fiber, plasticky cardboard blend sort of. So it's a bit more solid than cardboard, though it does look like cardboard. I think that what we'd probably want to go with is a sort of plastic. Like ideally, we'd like to kind of 3D print the entire thing, but we didn't really have the time span to be able to do that.
Okay. No, it looks very good. I guess one other thing, just a question, I guess, just hearing a little more about the use case. So if kids are putting food on it and things like that, is there any way that that crack could be protected below with the electronics, or is that protected at all? If drinks spill or crumbs and all the rest of it.
Yeah, that's a good question. Maybe having some sort of way that the tablet holder could sort of have maybe like some sort of plastic kind of going around it and surrounding it, making a bit more of like a tight, no kind of holes between the actual mover and the actual like board would be great. We were trying to implement something similar to that, but then we ended up having issues with the slider, meaning we had to make it more bigger. But yeah, having something like that would be great.
Good work. Thanks.
Can you just ask what added height your end design has is above the tray level?
I believe it's about 1 centimeter, maybe 1 or 2. It's not too high elevated above the tray because there are some components underneath that are also guarded.
Great, thank you.
Perfect. So thank you very much, D24. If I can get D15 to start sharing their screen, get ready to present. And as always, judges and clients, please fill out your evaluation form.
Perfect. Can everyone hear me? Perfect. All right. So here is our presentation. So this is Per Diem, an application to lessen your worries about your elderly family before sending them to an old age home. Well, not exactly. I should rephrase that. My dad's down the hall and I don't want to hear my plan for the futures. I should more say, this is Per Diem, a wonderful application thought up by our client Susan to address the vulnerability experience of people that live alone and alleviates the stress on family members and loved ones. After multiple talks with her and client meets, we found out that she had 4 fundamental needs for this application. A daily check-in and reset time. So once you check in the morning, it automatically resets for the next day. A custom check-in time to change depending on the user. The contacting of emergency contacts automatically after a certain check-in period and a buffer hour, and a dexterity test if you do miss that original check-in window, just to make sure everything's okay. So with this information, we specified our customer demographic to the elderly and the handicapped or disabled, whether that be anything. We looked at existing applications, figured out what worked and what didn't work for our client. We made a business model for our application, and we looked at expenses that we may need to use. And for this prototype, I should just say, thank God for free trial. So here's what we came up with.
So for a quick demo, let's suppose that my mom wants to use the app to feel safer around her house, so she can log in with her email. And as easily as that, she's checked in for a day and logged in with a standard check-in time for 10 a.m. So let's suppose she wants to set up her emergency contacts. She can do so by clicking on the Add Emergency Contact button. And let's say I'm her emergency contact to check her out every day and make sure she's doing okay. So I'm now her emergency contact, and let's test the notification she will get every day when it's check-in time. So when it's check-in time, she will get a notification from the app like this, it's time to check in. And then she can tap on the notification and she will be checked in for the day, and the app will know that she's doing okay. So let's suppose that she misses the check-in window that is 3 hours. So if she misses that, she will get a notification like, are you okay? You haven't checked in for the day yet. So at this stage, she needs to pass a dexterity test to make sure she's in great shape. So if she typed the word, for example, yes, she will pass the test, and then we can make sure that she's doing okay for that day. Let's suppose a final scenario when she haven't checked in at all for the day. And this is my phone right now. So if you can see at my phone right now, you can see that I got a notification, an SMS from an actual server that says, okay, Fer is not haven't checked in for a day yet, so you should check on her. Maya?
Yep, so this is a very basic prototype. We do have a couple of other functions that we've talked to Susan about that we are planning to introduce after the class. Just because of time constraints, we weren't able to do it. We do have a live prototype. Susan did check in this morning, as I've heard, and we are just very happy. So we'll take any questions.
I should start by saying this is amazing. I can see multiple people using this. Even for me, with my parents, I can see this to be used. Actually, at Canada Post, we developed a similar app, which is person down feature, because we have Android devices. So if a letter carrier is walking and he falls down, there is a notification, pretty much like what you guys showed. So yeah, there is so many things what you guys can add and plug in to what you guys have here. So amazing job. My only question is, I'm hoping all of the time what you have is customizable, right? Like when all of the timing is customizable.
Yeah, we have a setting screen. You can check it here. Right now, the only thing that is customizable is the check-in period, but in the future, you will be able to also customize the check-in window, right? How much time do you have, and the frequency of the safety prompts.
Perfect. Amazing job, guys. Yeah.
Thank you. I just wanted to mention, you did say for Android, this does work for Android and Apple, both. So it really is to whoever can use it.
Yeah,
Well,
this
that's
is my
even
Android
better.
phone.
Yeah.
This is my Android phone, and it's also running. Yeah.
I have a question on, sorry,
Sorry.
Just have a question on the, is this app, can this app be used with my iWatch, or can I use it in a wearable device? Because my mom usually, she doesn't know where her phone is. So I was thinking this is great, but would that be possible to use with a wearable device?
Yeah, it will be possible to extend it to WatchOS. Right now, we are getting a notification on a WatchOS, so we have that scenario already tested. If you get a notification on your phone, you will get also a notification on your WatchOS.
Oh, great!
device.
Thank you. Great job. Awesome.
Thank you.
Yeah, this is a really good idea here. I guess 2 quick questions. One is you get a text message if they haven't checked in. Do you get a message when they have checked in, or can that feature, have you guys thought about
No.
adding that?
So one thing that Susan really wanted is to not annoy your loved ones and your close relatives. So if you're check-in, your close ones, they don't get anything. It's really only after your buffer period and if you miss every safety prompt and the check-in period. We didn't want a text every morning being like, yeah, okay, she's fine, because it's just kind of redundant, and it's also something Susan really didn't want.
I really didn't want to lose my privacy. Part of this is so that people don't know what I'm doing unless I'm in trouble. So that was, and I really loved the check-in this morning. It was feeling a bit like somebody had my back, so I'm quite pleased with this.
Nice.
There are many software of this type in the market. What is the difference of this software compared with the other versions in the market?
Can I jump in here for a minute?
Go for it, Susan.
I wanted something really, really simple. I didn't want a lot of extra bells and whistles. I'm older, I'm not technically savvy. I want something that I can't mess up and that doesn't do anything that I don't want it to do. So I was going for simple, and there's nothing else on the market that is this simple and works on text. So
okay,
nothing I found.
So it meets your specs.
Yes.
Okay. Good.
Sorry, my second question was just what happens if the phone is off?
Yeah, as we have a backend server running the checking for all our users, even if the phone is off or the app is not installed or whatever, the server knows the users, and it has a routine of checking in constantly. So the server can know when the user has checked in or not. And if it hasn't checked in, it will fire the SMS.
Okay, thanks.
Sorry, I'll ask one more additional questions. How many emergency contacts can you guys add?
Right now, up to 3 as for users client specification, but we could add any amount of.
Any number. Okay, sounds good.
Another thing that we are planning to add that was in the original specs, but just wasn't the fundamental, is that Susan wanted them to get contacted one by one, not all get sent. Currently, it's everyone gets sent the text, but that is a function that we are planning to integrate, is that one by one you have the people, so it's not texting everyone and then everyone scrambling, just if one person can make sure.
Right.
Perfect. I'm glad to hear that the app worked for you, Susan. That makes me so happy. But thank you, everyone.
Thank you.
Perfect. Thank you so much, D15. So if I can get to D12 to start sharing the screen, get ready to present. And client.
Now, I don't have my forms to fill in. I don't know where to find them.
No, okay, perfect. I will send it to you right now.
Thank you.
The chat. So now you should have the chat window that just opened up with a message for you.
Google Forms, thank you.
My pleasure. So it's T12 whenever you guys are ready.
All right. Hi, everyone. My name is Peyton. We are group 1.2, and we have created a personal safety application. The problem we've set out to solve is that for people who live alone, it could be a significant amount of time before someone realizes something has happened to them. We have created an application with the main goal of keeping track of the safety of the users and notifying their loved ones when their safety is at stake. The unique part about this solution is that it is a simple process, yet very efficient in keeping track of the safety of the user and notifying the emergency contacts.
Hello, my name is Zachary. I will be running you through our team solution to our clients' problems. So essentially, our product introduces the optimal solution that ensures the safety of our users. It performs an automated process that asks the user to check in at least once daily. If the check-in is not performed, then backup check-ins will be sent, and if these are missed, the emergency contacts will be notified. Our solution respects the privacy of our users. It requires no additional hardware. It's very easy to use, it has a less than 5-second check-in time, and it's also an automated process.
Hi everyone, let me just share my screen so you guys can see the app up and running on my phone. Okay, and we're live. So as you guys can see, we're on the sign up page where the user can just enter their full name, their phone number. Let's just go with the test one. The time of the first check-in of the day when they're gonna get it, and the number of the other check-ins during the day. So let's say I want to receive 3 other ones. Also, the security question, Susan insisted on having a way so that the client, the user doesn't accidentally check send. So we decided on having like a 2-step process. Let's just go with these ones. And here we're running. So it uses my name. You're not checked in yet. So I'm just gonna check in. I need to choose the security question. If the question is wrong, the answer is wrong, it's gonna obviously say that. I'm gonna use the right one. There you go. And it's gonna use my biometrics. I'm gonna instead use my phone password. And there you go, I'm checked in. It's gonna, I use a smaller buffer time so that for demo purposes that we can see the notification being sent. It's going to be around 10 seconds. In the meantime, I'm going to be showcasing the profile page where we can see that we can customize everything that we chose in the sign up process. We also included an accessibility feature that allows the user to increase the font of the overall app. Here it's time to perform the check-in and we automatically get the notification. We hard-coded in the app that the user is going to be receiving 3 notifications. If they don't, the emergency contacts are going to be notified. Of course, I used a small buffer time for the following notifications just for demo purposes. This was the second one. I'll also demonstrate the font modification. And we're gonna get the last one. In this case, one of the emergency contacts are gonna be notified. Since I'm currently in Morocco, I can't demo the SMS part since I have a Moroccan phone number right now, but it's gonna be sending also an email. Here it says emergency. There might be an emergency. Amen. Vakri hasn't checked in. The design, as you guys can see, is very minimalistic and sleek. The dark theme is going to be good on the battery life so that it doesn't drain it out, and it's easier on the user's eyes. That's it for the demo. Thank you guys, and we'll be answering your questions.
That's really good. Quick question. What if they forget the password and so they keep entering the wrong one? Is there a way to get it back or to figure out what it is, or will that, will that start the process of sending out the message to the emergency contacts if they can't get checked in?
We wanted to add this feature, but due to time constraint, what we were planning on doing is having like a password that will override every other process. Let's say, for example, when Susan, like if she does the sign up for the first time, she can pick like a secret code that in case she forgets the password or like her biometrics doesn't work, she can just override all of that using that password, and we'll be knowing that she's conscious and she's aware of what she's doing, since it will be a security password that only her will be knowing.
Actually, just to add on that, there's always a solution for that, is to go to the profile section and add the new security question. And then when you do the check-in, you pick it from the list and you get to enter a correct password. But we'd have to make a feature for that to be able to pick that particular password that you're looking for.
I just have a question. The reason of that password is to check on the client if she is doing okay, or is it for security purposes? What is the real purpose of that password?
It's
that
one is to check the competency to make sure that they are actually okay from a more mental or emotional state, as well from just being physically okay and able to complete a check-in.
Thank you.
It's also to check that it's actually them who are doing the check-in, not another person.
That's why we also included the biometrics, where only her can like use her face or like Touch ID for that.
Thank you.
Hey guys, I'm impressed with all of the caliber of presentations, what's coming through today. Really, really good. So well put together, well presented. I do like that password login thing, as you guys explained. I feel if you have aged parents, it's one other thing we can keep an eye out, right, for memory loss and stuff like that. So it's a great feature. So that's great. Yeah, so no, I can see that being very, very scalable. So I have no other questions, and I think you answered one of my questions via Latanya and Christine. So yeah, no, thank you so much and great job.
Yeah, I want to add, since we brought scalability up, I just want to touch on the fact that it's already deployed on an AWS server, and I tested it. I performed a load test where I ran around 1,000 instances, because the hardest part of the app is managing a lot of multiple users, and the hardest part is sending like the email, so the mailer and the SMS sender. So I spent up 1,000 instances, and it sent all of them concurrently, and there wasn't any issue with that. So, yeah.
So I want to say I like that a lot. The other two features that I particularly like about this is I like the dark screen that saves battery. And I like the, oh God, this is my brain not functioning. I like the font size, the fact that the font size can be changed. So those are the two special features that I particularly like. Thank you.
Thank you.
Thank you.
And thanks for doing this work. This is lovely.
Perfect. Thank you very much, C12. Now, if C24 can start sharing the screen, get ready to present. And judges and clients, just please fill out the evaluation form.
So we're C24. Let me know if you can see the screen.
Yeah, we can hear you and see your screen.
Awesome. Thanks a lot. So yeah, so we're group 2.4, and our product is called Light Shield, and it's for the dynamically polarizing glasses project. So what's the problem? We've been working with our client Kate from the Canadian National Institute for the Blind to design a product for people with extreme light sensitivity. As it stands, in bright lit environments, it can cause pain and discomfort for people with light sensitivity. And we found that they typically need to carry multiple pairs of sunglasses with increasing levels of tint or darkness in order to help them feel comfortable. We've found that this is fairly inconvenient because they have to carry around multiple pairs of sunglasses, and it takes time for them to take them on and off, not to mention that they have to have hands-free to do this. So in order to design a better solution, we've identified some core requirements. Namely, we've identified that our solution needs to have adjustable tint lenses, meaning that the lenses can go from light to dark automatically. They need to automatically adjust to the ambient light conditions. The glasses need to enclose the eyes. This was a big requirement since we don't want light to get in from the top, the bottom, or the sides because this can cause discomfort for the user. And finally, we need a solution to have a fast response time, meaning that the lenses will go from light to dark quickly when the lighting conditions change to reduce the discomfort felt by the user. So we've explored the market to see what other sorts of solutions exist, and we've stumbled upon another company called Ampere that produces sunglasses with adjustable tint and a fast response time. However, this is not suitable for our use case since they need to be manually adjusted through a smartphone app, which isn't ideal, and they don't enclose the face, so light can get in from the side, top, and the bottom, which can cause discomfort for our users. So that's where our product LightShield comes in. It improves upon these existing solutions since the lenses have adjustable tint. They can go from light to dark in one piece. It has automatic and manual adjustment. It achieves this using a light sensor located on the front of the glasses, as well as manual buttons on the top that allow you to manually increment or decrement the tint. The glasses wrap around the eyes to not let in any light from the top, the bottom, or the sides. And it also maintains the peripheral vision of the user, which is a big requirement also, since if you were just blocking it, they wouldn't be able to see what's going on the side, and that was not ideal. And finally, the system has a very fast response time of less than a millisecond, meaning that it can quickly respond to changing light conditions and change the tint accordingly. So now I'll demonstrate the product. I'll stop sharing. Okay. So here are the glasses. And so as you can see, there's a light sensor here. If I cover it, you should see it gets lighter. So that's good. So if you go from a light environment to a dark environment, the glasses will automatically adjust the tint accordingly. We have some push buttons on top here that allow the user to manually make them lighter, make them darker, and that's going on this side as well. And it's all being controlled by a microcontroller, and it has an onboard battery, and the overall battery life right now is about 9 hours. However, there's a switch that can let you turn off the device if you're not using them, which will help you save the battery. We originally designed it to have a larger battery, which would have given us 13 hours, which would last for an entire day. However, they weren't in stock, so we had to go with a smaller battery. And then it can be easily charged with micro USB, so you can charge it overnight so that it's ready to go for the next day. So yeah, that's our product, and I'd be happy to answer any questions on that.
If you don't mind holding the prototype one more time above, like I just want to see the thickness of the microcontroller, if you don't mind. Yeah. Okay, it's not too clunky. Yeah. Okay.
Yeah, and if we were moving this into production, we wouldn't use like this board. You know, we shift it onto a PCB, and so that would really decrease the footprint.
Yeah, makes sense. No, amazing. I can see the usability of it, so it's pretty cool.
Yeah.
And you said you can even pull it out and do an USB charge towards the end of the day. Okay, that's cool.
Yeah, there's a USB charge port, if you can see. So yeah, you can just plug it in, and then it only takes, it's a small battery, so it only takes about like half an hour to an hour to charge fully.
Okay, so it's light sensor based and also button based if you want to manually do it. Okay.
Exactly. So it'll automatically use the light sensor to adjust to the lighting conditions. And if you find that you would prefer it to be a little bit darker, you can use the buttons to make it a little bit darker or a little bit lighter.
Can you set your preference by any chance, or that's not a feature?
Yeah, no, you use the buttons to adjust it.
Okay.
Yeah. And then one other thing that we kind of noticed throughout the design process, we were specifically designing for our client Kate, but we also identified that, you know, this product could be useful for other use cases as well. Like if you're driving, something like this could be valuable. If you go into a dark tunnel, you'd want the sunglasses to get lighter, and then when you come out, if it's really bright, to have it return to that. So that was another customer segment that we could identify if we were to move this into an actual production product.
What does it do with respect to like moistness? Like say, for instance, you're in a steamer, like a steam room. Does that, like the sensor work for like rooms like that, or?
That's not something we tested necessarily. I think as long as it's not super steamy, I would imagine that it should respond fine. Mhm.
I have a question. Good presentation and also good work. What is the resolution of the lens? Let's say when I wear these glasses, right? Is my resolution impeded by the screen?
I don't know if I have I don't think we've quantified necessarily the like, so well, what I can tell you is when we're not applying, like, so at the very minimal, it's blocking about 63% of the light, and then at maximum opacity, it's blocking 90%. So that's the window of operation. But in terms of resolution, it's I wouldn't say there isn't really noticeable distortion or
Difference?
anything like that. Yeah.
Okay. Second question. How long does the battery last?
Yeah. So with the current battery, like I mentioned,
Fully charged.
Fully charged to depletion is a little over 9 hours. That's with a 110 milliamp hour battery. We designed it for a 150 milliamp hour battery, which would have given us 13.5 hours, which would have surpassed our spec. However, they weren't in supply, so we resorted to a smaller battery as a result. And in order to prolong the battery life even further, we've added in a switch so that, you know, if you're going into a darker environment, you don't need to wear them. You can turn it off, and that way it's not always on. And so that helps prolong the battery as well.
Okay, thank you.
I have a question on if I have a prescription glasses, can this technology be applied to it?
That was something that so our client Kate, she does have a prescription, and that was something that we tried exploring. So with this particular technology, it's a liquid crystal display sandwiched between two pieces of glass. Now I'm not sure if that can be engineered to accommodate a prescription. I haven't seen that personally. For our client, she wears a pair of contact lenses, and then she puts the glasses on top.
Okay, that's the solution. Oh, good. Thank you.
Yeah, no, this is sorry, this is really good. I guess I had a similar question too about the prescription, but also just I guess to say like, so I wear transition lenses, and I was actually quite amazed at how quickly yours changed back and forth. These do take quite some time, and in the winter it's much worse as well. So is there any, did you notice anything if in the heat versus the cold or anything, or is that impacted at all? Does that change the time that it takes?
Yeah, so one concern that we did have to test throughout the development process was, according to the data sheet of these lenses, the operating temperature is around the lower end of the operating temperature. The lower end of the operating temperature is around like -20 to -10, and so we were a little bit concerned about that. So what we did is we did some rigorous testing of the displays in that kind of environment, and we let it sit out in the cold for a number of hours, and we didn't really see any performance degradation as a result of that environment.
That's really good. Good job.
Thanks. And yeah, I meant to mention it during the presentation, but we did look at transition lenses as well, and the drawback was the response time.
Perfect. Thank you so much, T24.
Thanks a lot.
So I can get D13 to share the screen and get ready to present. And judges and clients, please fill out your evaluation form.
Hello, everyone.
Volume on your computer. Just max it.
All right. Hello, everyone. Can you hear me?
Yep. Feedback's gone. We're good.
My name is Aaron Adam, and together with my team, we present to you Horizon Glasses. So a little bit about us. At Horizon Glasses, we empower people afflicted by photophobia to see the horizon. By providing dynamic polarizing glasses, we help our clients relieve their pain and regain their sight. A little bit about the problem. So photophobia affects the vision of thousands of people, causing severe pain and discomfort to any external light stimuli. With that in mind, our objective at Horizon Glasses is to provide dynamic polarizing glasses that minimize light entry and adjust the tint percentage based on external light levels with the option to manually adjust.
Our current prototype works by sensing the surroundings and the ambient light using a photoresistor and uses PWM technology alongside a microcontroller to variably tint the LCD screens. It can be manually controlled using a potentiometer and has modes between automatic and manual. It is battery operated and fully covers the vision of the afflicted person. Here's a photo of my colleague Aaron wearing the glasses. As you can see on the left, there's a non-polarized state being transparent, so that would be 0, and then a polarized state, so that would be 100% of dimming. Here are a couple of working views of our current prototype.
For our future work, we decided that we wanted to move away from 3D printing, which was how the frame was manufactured. This is because doing this can give us better seals around the client's face and head. So per each individual client, you could mold their face and create proper sealing from light coming in at the top near their forehead or coming in from underneath their eyes, as well as the in between the screens in the frame. We do have a little bit of gaps in between those spaces there, which we were able to fill in. But if we were able to, again, properly mold a little bit of a tighter fit, that'll improve our frame design as well. Additionally, the electronics inside of the device, they could use some insulation with their connections to avoid any accidental shorting and stuff like that. So right now, we're going to get our teammate Nadej just to do a live demonstration for you. So as you can see from the lenses, they are flickering a little bit. Full disclosure, they were working very properly and adjusting properly with the potentiometer. However, upon integration with the assembly of the frame, one of the connections is a little faulty, and that's why you see that little bit of flickering right there. But it does work, and we are currently working to fix this issue. Thank you for your attention. This is our presentation. Do you have any questions?
So I have a quick question. Are you guys just affecting the tint, or is there actually some polarization involved?
So these lenses, they don't affect polarization in terms of blocking out UV rays specifically. However, our client is affected by all types of light, not just UV light. So with any type of brightness is mainly her issue. So these lenses do limit the amount of brightness entering the lens, but not the UV they don't come with UV protection. However, our client does wear contacts that she could wear alongside these lenses, which would come with some UV protection as well.
Yes, you're just affecting the tint, the amount of light that's entering and not pulling it through a polarization filter, right?
It's not filtering any UV light specifically. Because even it's, again, like I said, it's not just, it's even like indoor lighting affects our client as well. So any type of lights, TV screens, etc. So one type of polarization wouldn't really solve for issues. It's more or less a matter of dimming all type of lighting.
In the future, it's always possible to add a tint that can, in addition to the LCD screen, polarize some of the lights. That could be something we could look into in the future.
Okay, thanks.
Question. So is it using a toggle button? What is making it go from light to dark?
I got this one. So there is a toggle button which changes with the mode. So there's an automatic mode which senses the ambient light using a photoresistor. And according to this, it will dim the LCD screen based on the coding that we integrated. And then the second mode, which is manual, is completely operated using a knob on the side. And that's just for manual adjustments.
So there is variation of lightness and darkness, is
Yes,
it?
absolutely.
As you can kind of see right here, this little knob right here.
Okay, perfect. And great job, guys. I love how you tag team for your presentation. So good job.
Thank you very much.
I have a question. How long does your battery last?
Well, okay, yeah. So right now, the way we are going to have it operated is off of two 6-volt coin cell batteries. We're going to use them. We use them in series just to supply enough current to our circuit. We estimate those batteries aren't very large, so we do estimate that they probably won't last longer than a week. But for sizing, but we could use a rechargeable battery, which is something that we're looking into. So we tested them with coin cell batteries, but again, we can put in a rechargeable battery, which again, that you can just plug in when you're sleeping at night, and that'll last however long that you need. It was more of just an issue for this project where we couldn't get a rechargeable battery specifically.
One thing I do want to add is that these LCD screens are quite efficient as they only require power to change. And say it's used in manual mode, if it is to be staying in one mode, it will not consume much power at all. And it's only when you're switching that it consumes power. So automatic mode would definitely consume more power than manual.
So how many modes do you have in this case?
2 modes, automatic and manual.
Okay, and then for the LCD screen, how many resolutions can you change?
It's based on the potentiometer, which is coded to 0 to 1024. So technically, there would be 1024 different
levels,
but it's a knob, so it changes gradually, and it's difficult to see the steps in the resolution.
Okay, good, thank you.
No problem.
Well, perfect. Thank you very much, D13.
Thank you.
Thank you. Thank you.
If I can just get D23 to share their screen and get ready to present. Judges and clients, please fill out your evaluation forms. So C23, whenever you're ready.
So, hello everyone. My team and I are going to present to you our mobile application for text-to-speech developed by Serene, Valentine, Jotushun, and myself. So I'll pass it on to Valentine now.
So the thing is, for people with partial visual impairment, it can be hard to navigate a visual world, especially nowadays as digital accessibility is becoming more common. This led to the creation of a user-friendly text-to-speech app that would use files of type PDF, doc, or TXT, and pictures from both device gallery and camera, as the available apps on the market don't allow for the selection of pictures or files already on the device. Moving on to the next slide. So before developing the app, we needed to define and classify the user needs according to their importance on a scale of 1 to 5, with 5 being the most important and 1 being the least important. So the app must be able to read out loud the text on the image or file. It must be easy to use and of low cost. It must have a convenient reading speed for the client. It must have access to the camera and must give user the choice to more than one voice. Moving on to the next slide.
So our solution was to create a mobile application that is user-friendly, of high contrast, suitable for multiple file types, and able to convert text to speech. Next.
So now for the product demonstration. So once the user enters the application, the first thing that they are presented with is the Splash UI or the welcome screen. So it just consists of the logo of our application for text to speech. And then we have the onboarding screen. So these are just the options. So it is kind of like a tutorial to explain the user what every option does. So here, for example, for the camera, it says take a picture from camera to convert the text to speech. And now here we have the main user interface. So you have the 3 different options. So going to the first option. So right now we have selected a picture that has some handwriting. So in this case, it is my handwriting, and it is some uppercase letters. And you'll see that once we press on the button read out loud, it will read it fairly accurately. And now this is some cardboard. So it is written Hello Fresh. And once I press on read out loud, it will read it out loud. And accessing the camera now, I'm taking a picture from my laptop. So this is one of our slides. And the application is able to extract the text and read it out loud. And now going to the files. So first we are going to try out PDF files. The stop button is working, as you can see. And then moving on to a .txt file. And the last test that we are going to do is on a Word document file. So our application unfortunately doesn't support Word document. And because of that, we had to cache that exception and say that the file isn't selected by the user. So thank you very much. That's all for the demonstration. And if you guys have any questions, we'll be happy to answer them.
So just
a question.
Quick one out of the gate. Assuming your users are partially visually impaired, how does your application deal with the text that's on screen or the menus cycling through the application? Is there some kind of voice activation or are text reader to speech for the actual application buttons?
Well, it is actually for partially visually impaired people. So it is not like they are totally blind. So for example, if you see in the demonstration, when we select a PDF file, so the text is extracted, but the user said that actually the text doesn't need to be extracted, but we kind of had to like have something, because if we have like an image, we wanted to like render the image to let the user know that they have like selected the appropriate file, but we couldn't really do that with a PDF. So kind of like had to extract the text to show it.
Yeah, but what I'm
That
saying
answers.
is at the beginning, when you open the app, it says, you know, there are 3 choices. You want to take a picture of a file or
Oh, right. Okay.
So in that menu, I'm assuming if the user can't read the HelloFresh box, that they might not be able to read the small text describing what's on the screen of the phone.
Yes, that's actually one of the suggestions, one of the feedback that we have received to kind of like for the tutorial to kind of like give the user the ability to hear that tutorial out loud. But unfortunately, we weren't able to implement it because we were kind of like short on time. And so we had to get the speech working on the rendering side of things. And we were short on time to include it at the beginning, if that makes sense.
Okay, thank you.
I have a question. Nice presentation. The question is, what if the handwriting is very hard for the system to recognize? What text would you produce?
Yes, so we have actually tried to do that because like as you could see, the handwriting was kind of like all capital letters, but I tried to do it. I tried to write hello world with lowercase letters, and it was hardly able to like pick it up. Like it tried to read something, but it wasn't like as accurate as it is supposed to be. So yeah, definitely there is some limitation in that side of things.
So what would it produce in your system? Let's say if the user say, I can do it, or the system will tell the user?
It would like try to read something like out loud. Like it would do its best to read something out loud, but it wouldn't be accurate.
But it will be gibberish in this case, right?
Yes, yes.
Yeah.
Okay. Good, thank you.
No problem.
I have a question with multiple languages. If there is another language, would they still read, or it needs to be specific for one language?
Yeah, so that's actually one of the requirements of the client, that the application would be able to like detect multiple languages and read them all out loud. But again, like due to some time limitation, we weren't able to like incorporate all of the different languages that we wanted. So the package that we have used is called text to speech, and it only like allows you to select one default language. So the default language that we have selected in this case is English, and we would like have to use a different package that is called Google Translate API that would allow us to make those like different translations between languages. So that would definitely be our next step.
Right, thank you very much.
No problem.
Any other questions from our judges? Perfect. So thank you very much, C23.
Thank you.
That concludes the team presentations for today. So the next thing that I'm going to get to do is I'll get all the judges to join the breakout room called Accessibility 2 Deliberation. So we'll all move over to there and proceed with the deliberation to pick the winner of the category. Clients and students, feel free to stay here in this room. Once the deliberation is finished, I'll come back and I'll tell everyone to go back to the main Zoom call for the closing ceremonies. Clients, this is a good time if you have any questions or you want to talk to specific teams. You can do so in this room, or you can go back to the main room of the accessibility category. Up to you guys. So I'm just going to exit with the judges over in the deliberation room. If you're not sure on how to go there, if you look at the bottom of your Zoom screen, there should be the breakout room button. It has 4 little squares. If you click on the breakout room button, you'll be able to then scroll down all the way down to deliberation accessibility 2. and then hit the join button next to it.
I just wanted to say that this is going to be a tough decision. Everyone did a really good job with all the presentations. It's been a joy to look at all this stuff and all this innovation that's coming through the pipeline. So congratulations to everybody. Thank you.
Very impressive, just knowing that it's the first year and the second year. It is really impressive what's coming. So thank you very much for letting us participate in this.
Indeed, thank you so much. I'm really looking forward to using at least one, perhaps both of the apps that were developed. So thank you. And I need help getting back to where the main thing is going to be. I'm on an iPad.
Yeah. So I will send the link in the chat to everyone. So
Great.
There, Susan, there's the link for the main.
Got it.
It'll send you over to the closing ceremonies.
Perfect.
Which should start around 12:25, I think.
Okay. Thank you so much.
My pleasure. Have a good one.
You too.
And you know what? I feel bad that I didn't take the time to do that.
Well, I felt